Hey everybody, this is Larry. This is day 18 of the 30-day Leetcode challenge. I'm a little behind, but that's okay. Let's take a look to see what today's challenge is. How are you doing? Hit the like button, hit the subscribe button, and let's solve this problem together, or put pause and then do everything you want. Okay, cool. Minimum path sum. Given an m by n grid filled with non-negative numbers, find a path from the top left to the bottom right which minimizes the sum of all numbers along its path. You can only move either down or right at any point in time. Okay, so this is you start from the top left and the bottom right, and you can only go down or right. So um, this is a very standard dynamic programming problem. One thing to kind of notice is that uh, there are no cycles, right? You can only go down and right, so there's no going back, and there's no loops, no cycles. And what that means is that there's a it's a DAG, which is a directed asynchronous graph. And what that means is that, well, you could just do a simple dynamic programming and then figure it out. So there are a couple of ways to do dynamic programming for this problem, and I think this is a good practice. It's a good beginner's practice for both what we call top-down dynamic programming or top-down memorization or bottom-up dynamic programming. The advantages are kind of depends on the problem, obviously, and you have to kind of have the experience to make that trade-off. But in this case, you can do either one, I believe. And usually the bottom up is necessary when you need to minimize or optimize the space. And I would recommend that you practice enough doing bottom up so that you don't need to maybe do it for every problem, but enough that you're able to talk about it articulately about how you optimize the space away, a dimension of space away, which is something that maybe we'll go over in future videos. Stay tuned. Hit the subscribe button. But yeah, so let's kind of go to it, and we could kind of, and the thing that is good about, at least for me, that I like about dynamic programming, is that um, because in a way you're doing an exhaustive search in the entire space. Just that there's certain states that repeat itself, right? Certain subproblems that repeat itself. But other than that, other than the fact that the subproblems repeat themselves, it is exhaustive search. So that for me, the proof is generally very intuitive as a result. But yeah, I'm going to start coding. I'm going to do the top-down, top-down memorization. And I'm going to take advantage of a library in Python that's called the LRU cache, which is probably not its its intention is not necessary for competitive programming memorization, but memorization is a technique that you use outside of competitive programming as well. Generally, you want to cache things so that, especially expensive operations or queries, so that most of the time it is very fast. So yeah, let's kind of get to that. So we could set up the LRU cache, and we just set the max size as equal to none. And I would implore you, if you're a little bit maybe still learning, maybe don't use the LRU cache. I mean, maybe use it enough to understand the problem. But then after that, rewrite your code to do the memorization explicitly so that you can understand the states and how to analyze it. And we'll talk about that as we go through the problem. But yeah, let's min path sum at, let's just say, because we want to do it at some x and y. What is our base case, right? Well, let's go back and set n is equal to length of grid, m is equal to length of grid of 0. You could do it the other way around. I think nowadays there's a movement to kind of move that around, but yeah. But either way, it should be okay. But yeah, but now you guys check that if x is equals to n minus 1 and y is equal to m minus 1, then that means we're at the corner. Then let's just return the value that is there. Otherwise, then now this is the interesting part, right? Well, what is the minimum path sum at this current location? Well, you could define it recursively, or in terms of itself, or in terms of its subproblems, right? The min path sum at x and y is just if you go down one, or if you go to the bottom, go down one or go to the right one, right? So let's take the min of both those numbers, and then we should be able to go. So let's just set the standard value to best is equal to some infinity. So let's just say infinity. Then we return best after we're done. But let's just say if x is plus 1 is less than n, that means we can go downwards. Oops, we can go downwards. Then that's, best is equal, best is equal to the min of the current best, perhaps, though in this case it probably would. And then grid of x, y plus the min path sum at x plus 1 y, right? Because you have to take account of the current grid. That's what I'm saying. And then now we check the other dimension, which is if y plus 1 is less than m, then best is equal to min best grid xy plus min path sum x y plus 1. And that's all you have to do, really. Maybe I need a catchphrase, but essentially now you just have to go min path sum at 0, 0, because that's where we're starting, and minus some potential off by 1, because I'm a little silly sometimes, and I'm a little bit careful, but that's why we test. Oops. Then we should be able to, this is also a little bit annoying. Whoops. For some reason I did the name wrong, but that's okay. That's an easy fix. So the expected answer is 1. So let's try something as basic as one number, 2 numbers, I guess. I mean, 3 numbers is fine too. And then after that, I'm doing a couple more edge cases, like one straight column. So let's try that. And I would say maybe negative numbers or 0 numbers, but shouldn't come up. And I don't know if the 0 input case is a real case, but let's try it anyway. Okay. And then now let's submit. And that's pretty much all there is to it. So so if you're up to this point, try to write it out as an explicit memorization, and also maybe convert this to bottom up and practice trying to get the space-time complexity down. And your question maybe, well, we did all this recursiveness. What is the space-time complexity? Well, the time complexity is, well, let's calculate number of states, right, or number of things that this hits up, and x could go from 0 to n, y could go from 0 to m. Okay, m minus 1 and n minus 1. But O of n and O of m, so together there's O of n times m states. And each state, we do O of 1 work. So the total running time of this algorithm is O of n times m. And of course, the number, so we store one result, which is the best sum, the min sum even, per cell. So this is now n times m space as well. And if you wrote this bottom-up dynamic programming, you can actually get this down to O of n or O of m space. And maybe we'll do that in the future, hopefully. But that's all I have for this problem in terms of the complexity. So as an interviewee, like, this is interesting. In terms of cleaning up the code, again, if I was talking about this in an interview, then maybe I would talk about convergence and bottom-up dynamic programming for the space complexity reasons. But other than that, I would say this is roughly very straightforward and really few places to optimize in terms of code. At least, like, not optimize, but clean up in terms of code, and just to make it a little bit easier to understand and read. In terms of, as an interviewer, this is a pretty straightforward problem. I think we've seen similar problems. May ask a different variation of this problem, a harder variation, but this is actually pretty cool. So that's what I have for this problem in terms of an interviewer. So actually, this is a really cool problem that I actually like. I mean, not necessarily for competitive programming reasons, but But actually, the minimum path sum is something that comes up for dynamically resizing, sorry, content aware resizing an image. And you could do a quick Google and all that stuff. But yeah. That's pretty much all I have for this problem. Um, the read up content aware resizing, and I think that would be really cool for you to kind of read up. Um, but otherwise, yeah, that's all I have for today. Thank you, and stay tuned, and check out my thing tomorrow. Because for the content aware image resizing, you can actually look at each pixel as a value from as like a value, and then you could try to get the minimum path sum of the delta of the values, like what they call the energy density from left to right. So that when you remove a line, it doesn't have to be a straight line. It removes like a weird circular line, and that circular line is the quote unquote least interesting line. And that's kind of how I would think about it. Okay, cool. I think that's all I have. Thanks for your time, and yeah, stay tuned. Bye bye.